This is quantum mechanics. Simply, quantum mechanics, in simple words, is the study of matter and energy at the most fundamental level. It's basically about reimagining reality itself. We can start with section 1. This is the quantum playground, where particles break all the rules. Imagine you're at a concert. The crowd does a wave. The wave is nothing but a rolling pattern that moves through people. Now, imagine a single person creating that wave and, as an additional, throws a glow stick at the same time. That is quantum physics. Tiny particles like electrons act as both waves and particles. This can be demonstrated by the wave particle duality, or the double identity act. Let's visualize two slits. These are meant to be thinner, but okay. They're slits. Now here, I would like to imagine two different scenarios. Let's call this the wave version and this the particle version. Here is the famous double slit experiment. If you shoot electrons like bullets, they make two stripes. Pretty self-explanatory. But when we don't watch, they act like waves, creating this rather striped pattern, as if each electron splits into two ghosts that interfere with themselves. This explains that at the quantum level, particles aren't just things, they are whole new possibilities. Nextly, we can see this further by the Schrodinger's cat. This is Schrodinger's experiment. Now let's visualize a box. that, let's say, has poison in it, and there is a cat. Now, before I go any further, let's do this in simpler terms. Let's imagine a coin. Imagine flipping a coin in a sealed box. There can be two states here. It's obviously either heads or tails. Until you open it, the coin is both heads and tails. Just like that, Schrodinger's cat is like that coin. It also consists of two states. Considering there's poison in the box, it's either alive or it's either dead until it's observed. In quantum terms, particles exist in multiple states simultaneously. Your observation freezes them into one reality. This summarizes that reality isn't fixed. Reality isn't fixed until you look. Quantum systems live in a maybe land. Now we can move on to the next section. Section 2. Quantum connections. Spooky action at a distance. Let's imagine two people. This is meant to be a woman, and this is meant to be a man. Now let's imagine they're holding orbs. This is connected by this zig-zag line. Okay, meet Alice and Bob. If the orbs are connected or quantum entangled, measuring one instantly sets the other state, even if they're on opposite sides of the galaxy. Einstein hated this, calling it spooky, but experiments confirm its reality. This takes away that entangled particles share a hidden language that defies space and time together. Nextly, we have the third section. Quantum magic tricks. This is one of the most interesting ones, per se. This is quantum tunneling. Now imagine a man, anyone. This is a wall. Now anyone humanly in their mind would know that it's impossible to walk through this wall and to teleport on the other side. So let's name this an energy barrier. So in our world, you can't walk through walls, but quantum particles cheat. They tunnel through barriers like ghosts. This powers the sun's fusion to your smartphone's flash memory. This is the Heisenberg's selfie problem. Let's just call it that. So let's imagine a spinning coil. Now this is again of two different parts. This is momentum and position. Now just imagine a camera. Okay. Now let's imagine you're trying to take a photograph of this spinning coil. If you catch it mid spin, this is momentum, you will blur its position. You'll stop it for a clear photo for its position, then you may lose its spin info. Quantum particles face this dilemma always. You can't know both fully. Momentum in this case is kind of like motion blur in photos. This basically shows that measurement changes what's being measured. This is the ultimate observer effect. Also, your phone is also a quantum machine. Like lasers, transistors, and even GPS rely on these rules. Even photosynthesis uses quantum tricks. You can try it at home by shining a laser pointer on a wall. Those photons are nothing but quantum particles that behave as waves. We can move on to the final section, section number 5. This is the quantum mystery. Well, what does it mean? I think everyone knows about parallel universes, and this is a conscious observer. So, here's the big debate. When you measure a quantum system, does it split into many worlds or many parallel universes? Or does it require a conscious observer relating to the conscious theory? And in reality, nobody knows. This is why the world never runs out of physicists, and that's the reason they all stay up late. I would like to end this by stating what quantum mechanics actually is and summarizing it in a paragraph. Well, quantum mechanics isn't just physics, it's a new way to see existence itself. Every time you charge your phone or stare at the stars, you're touching this hidden layer of reality. Quantum mechanics isn't always just theoretical about about complex equations and math on a blackboard. It all starts with a why that eventually challenges intuition, a person's intuition about how the world works, showing that at the smallest scales, reality is more probabilistic rather than deterministic. And just about anyone can go deeper in a vast subject like this. One can start by replaying this video, grabbing pencils and trying to sketch these ideas themselves to gain a better understanding. Finally, as Richard Feynman said, nobody ever understands quantum mechanics, but that's what makes it exhilarating.